So good timing. I'm going to hand over to Anya for the Maths in Space panel. Over to you.
Thank you so much, and welcome everyone to the Maths in Space panel. My name's Anya O'Brien. I'm a planetary science PhD student at the University of Glasgow. My PhD is all about the search for life on Mars and understanding if Mars is habitable. I do that by zapping Martian meteorites, which are rocks from Mars. I zap them with X-rays and lasers and try and search for evidence of organic matter. So that's carbon-based materials that we know that all life as we know it is based on. So it's a really exciting thing to be a part of right now. Today with Mars Day, what wonderful timing. We've just had the Perseverance landing. My research is so kind of inherently ingrained with Perseverance. If nothing else, there's actually a Martian meteorite on board Perseverance, which is one of the ones I study. So Martian meteorites are rocks that have been ejected off the Martian surface by a rock colliding with Mars. And then they floated off into space and they've randomly ended up on Earth. And on the Perseverance rover, they've taken a bit of one of those meteorites back. And it is one of the ones I studied. They've taken it back as a sort of calibration target to kind of see if there's like any changes over time, if it sort of degrades. And it's also just to kind of make sure the machines are all working as they should. Now, as a Maths in Space panel, obviously an important thing to say here is the role that maths has played in my career and does play every day. My background was in astrophysics from Susie's University of Leicester. And then I was actually a high school teacher for a few years. And then I started getting jealous of my students learning new science when I wasn't. So that's why I went back and did a PhD. There is a lot of maths in what I do every day, maybe unsurprisingly, maybe surprisingly, because what I'm doing is mostly geology. And you think, well, how is rocks maths? It comes into the statistics, it comes into the kind of graphs that I look at, it comes into the kind of probabilities of what I've found. There's all sorts of basically mathematical analysis I have to do with the data, which if I didn't have the background that I've got in a very maths heavy degree, it would have been really challenging. But most excitingly, most recent, you may have seen that there was a meteorite that fell in the southwest of England just about 2 weeks ago in a town called Winchcombe. I was really lucky. I was part of the team that went and found that meteorite. There was about 5 pieces that fell, and I was part of the search team that found one of them in a field full of sheep poo. And I tell you, it's really hard to tell the difference between a sheep poo and a meteorite. They're just black, shiny, small things. So where maths comes into this is we would not have known which fields to search if we did not have the mathematicians who could look at people's camera footage. And I'm talking even people who just had doorbells with cameras on and sent their videos in, meant that the clever maths were able to use that footage to work out a very small area. And I'm talking about a line where either only 400 meters either side of that line is where this rock fell, given that this thing came from the outer asteroid belt, which, by the way, they managed to work out which asteroid in the outer asteroid belt it came from because of the maths. So couldn't be more timely for me doing this today. Like I said, I literally just came from a statistics chat about the space sector, which is kind of relevant to my other role because I'm a diversity officer for the Royal Astronomical Society as well. So that's me. That's a whistle-stop tour. But I'll stop chatting because it's not just about me. I'd really like to introduce our Maths in Space panelists today. So first of all, we have Louise Mccall. She is a project manager for RAL Space for SDFC. And I'm going to ask Louise, give us a little overview of your background, how you got to where you are today, and particularly what has the role of maths played in that?
Hi, yep, I'm Louise, and I currently work as project manager at RAL Space. So there I work with teams of engineers to design and build mainly cameras for spacecraft, which look at, for example, the sun, or look for exoplanets, or observe the universe in ultraviolet, as it was a recent mission. So maths underpins most of the engineering that happens where I work, but then also related to my job, I have to manage the budget and the schedules and risk analysis and that kind of thing, which all involve like number and analytical skills. But my background is actually in theoretical physics, so maths played a very big role in most of my degree. And I kind of found that when we were at school, we tend to study maths and physics kind of separately. But maths actually underpins everything we do in physics and gives us a way to describe the physical phenomena. So I found that I enjoyed physics more and did better at it when at uni, and we did the maths and physics kind of alongside each other. And I liked how elegant the maths could be to describe very complex things in physics, even though the maths itself can be really, really complicated as well. It's satisfying where you can follow through a calculation and then directly link it to a physical concept. And in that way, maths is an important research tool, as a good mathematical model of something real can also tell us things that could exist, but we haven't done the right experiment yet to find them. So working purely with the maths and theoretical concepts can be very rewarding. But the other side to that is that not everyone enjoys the really, really intense mathsy side or doing research with maths. So maths is also a really, really important tool in nearly all of science and engineering, kind of as the background to your experimental computer modeling, relying on mathematical concepts. So, even if you're not the biggest fan of maths or find it challenging, that's certainly not a barrier to being involved in science and engineering. It's kind of more as a tool, but on the flip side, it can also be, in and of itself, a very rewarding way to do research. So I kind of found that I really, really enjoyed learning the maths and using the maths as a tool, but I was kind of less keen on doing the research purely with maths. If it's just, when it's just you and the maths on a piece of paper and you get stuck, you can't go and like fiddle with an experiment. All you've got is you and the piece of paper. So that's kind of why I decided to do something less directly mathsy by becoming a project manager, which gave me kind of more direct involvement in the space sector. So now I get to work with lots of different scientists and engineers as a project manager.
Fabulous. Thank you so much, Louise. That was, I just think, a really wonderful insight, especially the kind of elegance of it. People don't really think of maths as like sexy, but it can be quite an exciting, like elegant, sexy thing when it all fits together and you solve it. And yeah, sorry, that sounds daft, but to me, I think it's really important thing to say is that there is this satisfaction that comes from it. So thank you so much. I'm going to go to Ingmar next. Ingmar is the Education and Outreach Manager for the UK Space Agency. His job is to partner and collaborate with institutions and organisations across the UK to draw children's attention to space, STEM and careers in space. So Ingmar, please give us an overview of your background. What's your relationship with space? How did you get to where you are? Tell us all of that, please.
I'll tell you everything. I'll tell you the whole story. So I've always been absolutely fascinated by space. I don't know where or when it began, but even like very young, I was into space Lego. So I had like spaceships and like space stations and all that kind of stuff. And I went on to study mostly science. So I did maths, physics and chemistry at A-level. So maths kind of came with me all the way through. At the time, I didn't really know what I was going to do with it. And then the space kind of theme in the back of my head led me to study astronomy. So not too far off what you did. Mine was slightly more in the realms of the practical astronomy rather than the kind of the astrophysics side, but there's a lot of astrophysics. There's a lot of crossover. And I found during the course of my master's, because I hadn't studied further maths at A-level. So maths at A-level is split between maths, and then you can actually do the more advanced stuff in further maths. At the time, I didn't even really know that existed. And when I hit my astronomy degree, I was hit with this kind of like, wow, there's some really serious maths out there that I wasn't even aware of. And I mean, as Louise said, it is an incredible tool, an astronomy and practical astronomy. When you're looking out, we're on the Earth and we're looking out into the universe. All we have is what we can see in terms of the electromagnetic radiation that's kind of hitting us from the Earth. And we can use maths integrated with physics to work out absolutely incredible things. like how stars are formed, how solar systems are formed, what stars are made of, how they're scattered in the universe, how the universe formed itself. So there's so much. But I found that I hit what I would probably call the maths wall, which is kind of like, I don't know, probably like, when marathon runners hit the wall and kind of think, I've kind of hit the place. I kind of just don't really get these concepts that well anymore. So I realized I probably wouldn't enjoy carrying on with astronomy, despite the fact that I really enjoyed learning about it and learning about, how does the physics, how does the space around a black hole work? And you need to, you need those mathematical tools to kind of work that out. But I was more interested in kind of practical things. I was going to potentially go off into maybe satellite telecommunications, designing telecom satellites, that kind of stuff. But I'm also a musician, very much a creative person as well. So I went off into the music industry for a long time, actually, doing logistics. But maths was still really useful in that. It's, I was doing all kinds of logistical work and a lot of finance work. And when I finally came back to space in the space agency, I was working on a telecommunications program. So kind of going back to where I was, where I thought I was going to go originally. And that's very much where the space agency is helping new companies, even and established companies, do really, really innovative technology R&D programs for making new satellites and new ways of communicating using space. And so again, maths came into that in a huge way, in just understanding the concepts involved, but also we're investing. So there's a lot of investment finance involved, a lot of managing budgets and all that kind of stuff. And now, as you said, I've moved kind of across into education. So now my role really is drawing attention, as you said, helping children, helping teenagers, even adults kind of understand space and the opportunities that can lie within, a space career. And in this case, how maths might help you. Or, another important point is that you don't necessarily need to have, as Louise said, like a very, very high level of maths. The space industry is a very, very broad place. So depending on where your level is, I hit my level, but depending on where you are, there are so many different directions you can go in. So yeah, maths features so heavily in space, like navigation satellites, teaching kids about how a navigation satellite works using mathematical principles to tell you where you are on the Earth. So there's a huge spectrum of stuff that I kind of get involved with, but that's probably good enough.
No, that's wonderful. Thank you so much, Ingmar. I'm really pleased that you kind of addressed that wall, as you called it, the barrier that maths made for you. And I think one thing that we don't talk about often enough in the space sector is the kind of challenges that we face and kind of having to overcome hardship. And yeah, we're not always getting it right. You don't have to be a genius that is perfect to be in the space sector. So I'm just so glad you sort of opened with that. So let's have Phil's opening now. Phil is a space vehicle architect. How cool is that? Space vehicle architect working at the Earth Observation, Navigation and Science Division at Airbus. So please, Phil, take it away. Tell us your background. Tell us the role that maths plays in your role, and you'll need to unmute yourself just as a...
Yeah, I spotted that. And thanks, Anya, and thanks everyone for having me here. So yeah, I am a space vehicle architect. It's a very grand job, and I think it may well never change just because of the job title. I've been at Airbus for about 1.5 years now. Prior to that, I was a space scientist at DSTL, the Defence Science Technology Laboratory, as part of the UK MOD, for another 1.5-ish years. Before then, I took a master's in science in space engineering at the Surrey University between 2016 and 2018. And coincidentally, it was there that I was diagnosed with dyslexia, which was nice. And that was following like 27 years in the Air Force, where I was undiagnosed. In the Air Force, I was mostly working with aircraft maintenance and engineering. So although I did maths in my engineering course, in my sort of engineering training as an apprentice, to a relatively high level, but it was very much treated as a tool. So how would you make a circuit that resonates at a certain frequency? We had all the equations given to us to make those sort of design judgments. But after going through the course, the amount of maths that you actually used whilst fixing an aircraft was quite limited. And before that, I failed my first year of A-levels, which is why I joined the Air Force in the first place. So that's kind of the career history working backwards. I was never particularly good at school because I was dyslexic. My maths in secondary school, in GCSE maths, I have no idea why my maths teacher decided to bump me up a level for the exams, but he essentially, I'll give him his name. His name was Trevor Richardson. He was an amazing guy. And for some reason, he decided to put me into a GCSE exam where the top grade you could get was C, whereas the rest of the people in my group of maths, the top grade they could get was D, which would not have been good enough to go to A-level. So he kind of opened the door for the rest of everything that's happened in my life. How do I use maths in an everyday sense in the job? It's mostly similar to Louise, so it's planning and management and risk analysis and stuff like that. But because I'd not done a lot of maths for a long time, before I went onto the masters, I did like 6 to 8 months of learning up to around linear algebra sort of level, using the Khan Academy, which is an amazing resource online. It's superb, and I learned loads there. But even then, it was still not enough to be comfortable on the master's course. I learned a lot on the master's course as well, and that's all comes back to sort of having, as both Louise and Ingmar have said, having this sort of tool set that you can use to solve problems. I was thinking about it quite a lot recently because of this panel, and because of dyslexia, I kind of liken maths to language. So we can all, most of us can write sentences, we can all write shopping lists, we can all use language to that, or English to that sort of level, but not all of us can write Frankenstein, Mary Shelley's Frankenstein, or something from Margaret Atwood or Shakespeare. And you can draw the analogy across to maths, where we can do arithmetic. Some of us can do sort of higher level sort of application of equations, and there are those few people who need to write the masterworks, but they're few and far between. For most of us, we can get away with knowing the equations and how to move them around and be able to write the equivalent of a letter. I think that kind of sums it up.
Yeah, that was really, again, I just really appreciate the honesty, Phil. I think opening up about things like dyslexia is so important, just to show people that, you know, it doesn't hold you back as a person. You can still have like such a wonderful job, you know. It's in some ways, like in some ways it's a superpower, a lot of things like this, because if you just think differently about the world. So just going to put the next question to you. We've had some wonderful questions in the chat, and I'm so grateful. Thanks to everyone getting involved in the Q&A. But we've had a couple of questions from, I believe, some primary school students about what maths is needed to get a rocket to Mars. Big loaded question there, Phil. Do you want to give a top level, what kind of maths? How hard are we talking? What do we use to do it? You talked about the people who write the stories versus the people who use it. Where does that come in to send a rocket to Mars?
So it's not, I don't think we're inventing fields of maths to get to Mars. We're using established things, and people like Robert Goddard at the start of the 20th century, and is it Tsiolkovsky, I think, was the Russian's teacher, who sort of derived these equations for how to get a rocket up. Well, I think Goddard's first rocket went something like 41 feet in the air, but they got the equations, they wrote those equations, derived them. So you need those, obviously, but then there's so many more. Again, we were thinking about this because of the panel, and it goes from working out how many turns you have to take on a screw to get the right torque, the right sort of stiffness, how tight should it be for it to survive, like some of the other panels have said, for it to survive not being shaken loose. And the maths in that is incredible, and it's really detailed. But then there's like big equations like, how do you get this 1-ton rover into orbit? And there are tools and stuff to do all those things. They're really interesting to use, and there is, like as people have said, there's a real sense of satisfaction when you actually get the answer right. It's one of my interests is applying that to a video game called Kerbal Space Program. So I try to design my own space missions using the maths that I know and applying it in that make-believe world and seeing how close I can get. So it runs through everything. It's incredible.
That's wonderful. Thank you, Phil. I really like this idea. We are this whole kind of standing on the shoulders of giants, right? Korolev, Goddard, von Braun, all these people in the sort of early to mid 20th century who figured out, right, here's how rockets how we do rockets, for whatever better word. And here we are now with computer games that can use the maths that they developed. I think that's wonderful. I'm going to go to Ingmar next, based on, we've had a lot of questions from primary school students in the chat, all about what kind of maths do you need to be an astronaut? What do you need to do to be an astronaut? How do we get into rocketry? And I feel like, as the education manager, responding to some wonderful enthusiasm from primary school students about, yeah, what do we need to do? I think you're the best person placed to answer all of that.
Sure. So, I mean, the criteria for becoming an astronaut has actually changed quite a lot from where it all, from where it began. Actually, astronauts used to be, originally they were kind of all test pilots and all kind of military based, but now astronauts can be from actually kind of almost any kind of background. You do need to have, I think, a master's degree in some kind of science discipline, or you need to be still like a test pilot, something like that. But it's not specific. ESA have just, they've announced that they're going to be recruiting astronauts again, and I think that recruitment starts end of March. And you can go onto the ESA website and you can have a look. There's, they've got a lot of detail there because this is the first time they're going to be recruiting again. I think for about 8 years or something like that. So now is a really, really good time to find out, what you need to do. You can go directly on their website and have a look. you can even apply. You can kind of have a go through the selection process and see what kinds of things you need to do. It's I think now it's more about you being kind of passionate about space and exploration and being really good at what you do. So it doesn't necessarily matter if you're a geologist or an engineer or a biologist. You know, there's all kinds of different people are really useful as astronauts because they have all these different backgrounds and they can apply those in that microgravity environment to do experiments. I mean, an astronaut's life mostly is doing experiments. Obviously, they have to do a lot of engineering, a lot of maintenance, but most of what they do, if you kind of, you can have a look on YouTube, have a look at some of the videos, especially that Tim Peake has put up about what his day-to-day life is like. Most of that is in, conducting experiments. Now, the future, if you're in primary school, and you're going to kind of be, by the time you're a bit older and you're kind of actually very seriously looking at becoming an astronaut, by that point, we would probably have successfully had astronauts back on the moon. Maybe there'll be a permanent base, kind of a permanent space station around the moon. We may even have had the first astronauts actually on Mars. That is the kind of ultimate goal in terms of human space flight that the UK and a number of other space agencies around the world are working towards collaboratively. Artemis is the first program which will go to the moon. But ultimately, all these organizations, all these governments, and private organizations like SpaceX, they're really trying to go to Mars. And at the moment, who knows what kind of criteria you would need to be that kind of astronaut, because that's a completely new kind of astronaut. Someone who's going to go all the way, to a much, much further part of the solar system. Who knows what kind of skills you'll need. But I think the key thing, if you're at the moment studying, is just find what you're really, really interested in. Go off and explore, try different things, look at different subjects, find the thing that you really enjoy doing, and then start getting good at that. And work as a team as well. Learn to work as a team, because that's a real, real key part of being an astronaut. You're always going to have to work as a team. So I think those are the kind of things that, as a primary school pupil, that you could get started with.
Thank you so much, Ingmar. And I am so glad you ended with that teamwork thing.
Yes.
People often ask me, like, what's the best thing about working in space science? And apart from having a bit of Mars on my desk, which objectively is, all right, definitely the best thing is the people in it, the people I get to work with. Whenever you meet or see any astronauts interviewed, by gosh, are they just such friendly, charismatic, calm, excellent communicators. And I really think what people call soft skills, but I would be corny and call them essential skills, are so important. If you can keep calm, if you can deal with failure, because by gosh, space is hard. So really, really think it's brilliant to have mentioned teamwork there, because it is a whopping great big effort to put something into space, which brings me a wonderful segue onto Louise, which is that a project manager's sort of job is to kind of put all the things together for a mission. So Louise, I'm going to ask you a small question here, which is, what would your role be, or how does your role fit in a mission to Mars, and what are all the things you've got to think about in a role like yours? I know your work is not specifically Mars missions, but what you do is run missions in space, right? So what do we have to think about?
So like all space missions, whether it's Mars or otherwise, it will always involve, there's the mission itself, then you've got all your science instruments that will go on your spacecraft, and then you've got all the different subsystems within them. So my department, a lot of us work on cameras to go on spacecraft instruments. But my group also did work on the Raman spectrometer, which is going on ExoMars to help identify minerals in the soil. So in terms of kind of planning and organizing all that, you'd normally have a project manager in charge of managing that subsystem. So for example, if we're building a camera, I would put together a schedule kind of saying how long it should take us to design it, how long it will take us to then test it, build it, do the environmental testing. So that's where we shake our camera to make sure it won't fall apart and we launch it into space. We also put it in a vacuum chamber, so suck out all the air, make it really hot and really cold to make sure it'll still work once we get to space. So kind of in all kind of general missions or even just projects that are part of missions, there's always kind of someone there making sure that it runs on time and it runs to the right amount of money, just kind of making sure that it's all kind of going along the way it should, so you can all achieve what you want to achieve.
Awesome, thanks, Louise. And I'm going to do a follow-up question sort of based on what things we've had in the chat, which I guess would come into something like a project manager, is how do we think about when to launch a mission? We've had questions about how many are launched, what time of day, what time of year. What are the things we have to think about, presumably in planning this out? Is it a time of year thing? Is it a location thing? Yeah, when how do you decide when you're going to launch a mission?
So for us, we don't directly launch anything. We normally give to somebody else and they'll sort all that part out. But when you are deciding when to launch a mission, you're kind of looking at when is the best time. So for example, if you launch something to Mars, there are different times in the year where the Earth and Mars are close to each other and really far apart. And you don't want to launch it when they're really, really far apart because it'll take a lot longer to get there, have to take more fuel. You can then put less science instruments on your rocket and that kind of thing. So if we're launching stuff, to Mars or to a certain orbit, for example, you want to make sure that you're launching your spacecraft so that you can get there using the least amount of fuel, that you're not going to, crash into any other spacecraft that are kind of in the same area. And it will also depend on kind of what the rocket is you're launching it on, kind of when they're available, where it's launched from. And then kind of on the day when it's launching, I don't know if anybody has watched any of the recent launches. They often get delayed for weather because you can't really launch if the weather's wrong and that kind of thing. So there's a lot to consider in terms of when and how to launch, depending on where you're sending your spacecraft. Awesome,
thank you. Hopefully that gives our viewers an idea of just all the different things that come into it, and that's just in the launch side of things. And I guess this would be good for Phil because we've had so many wonderful questions about the rockets. So and we've only got 7 minutes left, so I'll do this question and then we'll just finish up from everyone. So Phil, tell me, how do you go about naming them? How do you what goes into coming up with a design? How do you go into what happens in designing a rocket, coming up with a name, and just they're all quite different. So what goes into all of that?
That's a really complicated question. Who asks that?
I think they're an 8-year-old, which is pretty astounding.
In which case, they should start. They should really be thinking about taking this up as a career. How do they name rockets? I think probably that's going to come down to the company, right? And it's a communication thing where, for example, the States, when they were planning the moon landings, they wanted to call it something, so they chose Saturn. Whether there was a reason for choosing Saturn as a launch vehicle name, I don't really know. The same with SpaceX. Falcon is the names kind of drive a certain mental view of the rocket. So I think they're probably trying to elicit that kind of capture the imagination moment in what they choose to call the rocket. What was the rest of the question?
It was just about kind of what goes into designing it. What are the things you have to think about in being an architect of a launch vehicle? So
one of the things that you're going to want to know is what range of mass weight of objects are you going to try to lift? And that's going to play heavily on the rest of the structure. So if all you want to do is throw, say, 10 kilos of payload of satellite into space, your rocket doesn't really need to be that big. But something like a Falcon 9 from SpaceX, or the PSLV, the Polar satellite launch vehicle from India, they can take a lot of payload. So sort of, I think up to about 5 tons. So those necessarily have to be bigger. And what you tend to find is there'll be a prime mission that buys a launch and then offers opportunities to put secondary missions on the launch vehicle to try to like come up with some extra money for the massive amount of cost it is to actually launch stuff. Does that help to answer it?
Yeah, absolutely. And I think it's something maybe people watching might not consider, which is the difference in rocket size depending on your payload or what it is you're putting in space is huge, right? You're putting a CubeSat in space versus a person and all the support systems for a person. 2 years ago, 2020 is a thing. I sort of forget that that 2019 wasn't a year ago. I actually went to Texas, to Houston, and got to walk alongside a Saturn V that is in its big hangar. And it is so big. I'm a space scientist, and I couldn't believe how big a rocket needed to be to take people to space, or to the moon even.
And you compare that to like the Electron rocket from New Zealand, and that's only sort of 20 meters or so. But that only lifts like a couple of 100 kilos.
Yeah, exactly. The scale of it is just kind of unimaginable, really, in terms of the difference. So I'm just conscious of time, so we're finishing up now. So I'm going to ask for one last thing from each panelist. I would like to hear from you. What's your favorite thing about space, or what is it that if you were going to convince someone here, this is why you should do space, go into the space sector, what is that reason? So I'm going to start with Ingmar, no pressure. What's your reason? If you're going to tell someone, go and work in the space sector, what is the reason for that?
Gosh, well, I mean, from my point of view, I think it's because it is so big and broad. Just as space is itself, I mean, there's loads of amazing questions, which shows how interested people are in space, because it is fascinating. Someone was asking about the kinds of numbers involved. Well, if you think about the size of space, the number of stars there are, just the fact that we are, we're kind of like a tiny, tiny dot. If anyone manages to go and have a look at the pictures from Perseverance, there's a picture where you can see Earth as a tiny little star, or the Earth as a dot from one of the probes that went out. I think it was Voyager, and you realize how big the stuff beyond our atmosphere is. And it's just curiosity. You want to know what's out there. You want to go and explore it. And it's amazing for Earth. We use space in so many different ways to help us on Earth, from finding where we are, when you're in your car and you want to know where you're going, to looking at the weather, looking at the atmosphere, looking at the Earth in so many different ways, communicating, so it's such a broad field. And I would encourage anyone to just go and have a look, go and explore the different options, look at the different companies there are in the UK that cover all of these different kind of subject areas, and all the different careers. And, from a maths point of view, maths is, I think, kind of like a train. You can carry on with it to wherever your understanding leads you, and your curiosity leads you. And every stop along the way, there are careers and opportunities within space that you can just jump off and go, right, this is my level of maths, but here are all the different things I could do with that level. So do you do need to, math comes into pretty much everything. So it's a good thing to study, but you can choose how far you go with it and then what kind of careers you go with. So it's an amazing and fascinating place. It's very big. And in the UK, it's a growing sector. There's more and more and more things happening, and we're looking at more and more kind of diverse ways of using space. So it's a very big kind of industry to kind of get into. So lots and lots of opportunity. If you're fascinated by it, go and have a look.
Thank you so much, Ingmar. Not really got much time left, but Phil, if you've got anything to add, what would you say to convince someone to work in space?
I really like Ingmar's analogy of the train. It's really effective. You can get off at the stop that suits you and do whatever you want. And I wasn't sure whether I'd have the capability to work in space. And the lecturer who got me into the course said, it doesn't matter how adept you are at any one field, the whole or any one discipline, the whole field is so diverse. There's so many things that need to be done that there's a role for everyone and anyone. And I think that's the one thing to sort of take forward. One thing we lack in the UK is there's a real sort of shortage of people interested and people sort of thinking that they can do it, because the thing is we always think that it's beyond us, but yeah, I can honestly say it's not.
Thank you so much. I think that's such a wonderful thing. Yeah, like we've sort of running thread through this is the kind of resilience and knowing that it is for you, even if it seems like it isn't too hard, it is achievable. So finally, Louise, no pressure, after we've had the metaphor of getting off the train when it suits you, we've had thinking about going for things you might not feel good for. What's your message you want to end on?
So I think just the possibilities are endless in space, and like it's a real testament to kind of human achievement to what we've achieved so far. Like having a constant presence in space for over 20 years, sending rovers to try and find life on Mars, and looking so deep into the universe, like the Hubble Deep Field, for example. It just kind of shows us that we have learned so much by kind of addressing that final frontier. But that also is there still is so much more that we don't know and is left to learn, and there is a place in that discovery for everybody.
Wow, thank you. What a wonderful way to end. Listen, thank you so much to everyone who's been on my panel. So to Ingmar, to Phil and Louise for being wonderful just people to chat to, really. And thank you so much to the incredible Q&A. I've had way more questions than I could remotely have asked people, but the fact that we've had so much engagement from people of all ages is phenomenal. So please don't lose that.